Hi, my name is Pete Shoemaker and welcome to the Pacific Energy Center. I'm standing in front of a model of a home that shows how sunlight falls differently at different times of the year. This is one of the tools we use here to assess solar energy. Now, 5 years ago, I was in a position similar to that of many of you. I was a homeowner thinking about solar electricity for my home. I had to answer a bunch of questions. One, does this stuff work? Will it work on my home? And, most importantly, can I afford it? Well, I did the research, I bought a system, and now I get to share that knowledge and that experience with you. For the next 30 minutes, we'll have a class in solar basics, and we'll go out in the field and see an actual solar system being installed. 30 minutes, solar basics, stay with me. So let's talk about the technology. What is it and how does it work? There's three types of solar, actually, when you talk about solar, and I think I want to avoid the confusion to make sure we're focusing on the right one. Two of them involve heating water, and they're very viable technologies, can be very cost effective, but we're not going to deal with them right now. One of them is solar pool heating. Basically, it pumps the pool water up there, heats it, runs it through there, the sun heats it, and back into the pool. This one is called solar thermal, or solar hot water, and it heats what's called domestic hot water, or DHW, if you ever see that acronym there. And that's your hot water that you use for showers and dishwashers. But we're going to talk about solar electric, or photovoltaics, or PV. They have the same technology as computer chips. They're very similar in structure to that kind of transistor-like computer chip technology based on silicon. And the best thing about them is there's no moving parts, and they last a long time, a very long time. There are cells, modules, and arrays. A cell is one of these pieces here. It's a small unit of this transistor-like material wired together in a certain way to produce about half a volt. And these are hooked together in whatever size to be a module or a panel. Those terms are sort of used interchangeably. And then you hook as many of these modules together as you need to for your array. So it is very modular and very adaptable technology. You can put it whatever size you want. There's two sort of competing or comparable technologies on the market. Crystalline is the one that's been the longest, and it's made from crystals. So it is firm, hard like crystal. They're over 85% or 90% of the market now, and they have the highest efficiencies. In other words, they'll capture more of the sunlight per square foot than the other technology. This can be significant, especially in a city like San Francisco, when maybe you don't have a lot of roof space, but you want to get as much power out of it as you can. This is probably the choice preferred for most homeowners. The second technology, which is coming on strong now, is called thin film. And that's really a whole different technology using a lot less material. And it's almost like sprayed or painted on, a different way of producing electricity. This stuff has a lot of potential because it can be used in a lot of different ways. This is a thin film panel here, right here. And one of the innovative ways you can use this thing is on those metal seam roofs. These panels have an adhesive backing on them, and they can actually just stick down on the roof without penetrating the roof. And it's a very effective and cheap and safe installation process. Thin film has a lesser efficiency. It's about half as efficient, but it's about half the cost. So if you look at it, a small system, 1.2 kilowatt system, which means it produces 1.2 kilowatts in full sun or 1,200 watts. That's a small system typically. In crystalline, it would take about 5 of these panels, whereas in thin film, it would take this much space. Now, these two systems would produce the same, and at current prices, they'd cost close to the same. Let's take a look at the typical system components here, and then I'll show you how they're laid out on the house in a minute. We know what the array is. They're a bunch of panels hooked together. These panels are mounted to the roof by rails and mounts. They're hooked together with wires and switches, and there's things like that. We call all that the balance of the system, and it's a relatively minor component as far as price goes. So your array is mounted to the roof, typically. It's wired to the inverter, which is really a simple device that changes DC current to AC current. That's all it does. It fits along the side of the house next to the meter, typically, and isn't very large, about this big, a foot square, maybe. So that's the component. These typically are warranted for 10 years. They'll probably last 15 years. So in a cost analysis for the system, typically we'll run an inverter replacement at year 15. And then the inverter is wired to your loads. And loads is a word for anything that uses electricity, appliances, refrigerators, whatever. And it's also tied to your meter. The only real visual impact on the house is the panels. The other stuff is almost never seen. The thing about solar panels is they work during the day, obviously. So the big question is, what about at night or when the sun isn't shining? Well, in the past, the only solution you had to that was batteries. So you would have to purchase a large group of batteries, wire them to your system. During the day, the sun would produce what your house needed and would charge up those batteries, keep them ready, and at nighttime you would draw off the batteries. So what has made solar go from a niche market and explode it to hopefully a big popular market has been a breakthrough called net metering. Because the sun shines differently during different parts of the year, it makes sense to go for a whole year before you settle accounts. So you get a statement every month, but you don't have to pay it unless you want to. Your credits or debits roll over from month to month, and at the end of the year you settle accounts. The key concept, it's kind of magical in a sense, the utility grid is a two-way street. You can send electricity back up in the lines. Because you can do this, in effect, the grid can take the place of your battery. It reduces all the cost of maintenance of electricity, and it ensures a constant supply of electricity, because if you're tied to the grid is always standing there ready to serve you. During the day, it's charging a lot of power. My kid's at school, my wife's at work, I'm at work, so there's not much going on. It's just feeding my refrigerator or whatever. So most of my power is excess, and it's being sent back into the grid. And my meter is spinning backwards and banking credits to my account. At nighttime when I come home after work and the sun isn't shining, then I'm buying back electricity from the utility, basically drawing off my, quote, virtual battery, in a sense. But think of it as an economic transaction. So you typically sell back during the day and buy at night. And that's how it works.